Okay, welcome everyone. Today we're going to be learning how to solve trigonometric equations. This is Chapter 5, Section 3, Day 1. Our first example, in these problems we're going to be given a trigonometric expression set equal to something else. And we're going to solve these just like we would any other sort of equation. If we perform an operation on one side of the equation, we have to perform the same operation to the other side. The tricky part is realizing that terms work the same way with trigonometric expressions as they do with variables. So you can only combine like terms. This 2 tangent x is all one term, and it's just like this expression on the other side of the equation, this tangent x. So we can actually combine those terms. We can combine those terms together. The negative square root of 3, that's a different type of term. We're not going to be able to combine that with the other two, so we're going to have to move it to the other side of the equation. So that's going to be my first step. I'm going to add the square root of 3 over. We can always do any operation to one side of the equation as long as we do the same thing to the other side. And now I'm going to combine the tangent x's. So I'm going to subtract tangent x from both sides of the equation. So we have 2 tangent x's minus 1 tangent x. We can simplify that to just be 1 tangent x equals, and since the negative square root of 3 and the plus square root of 3 are gone on this side, it's equal to, the tangents are gone on this side, it's just equal to the square root of 3. Okay, so now that we just have a single trig expression equal to some sort of ratio, we can use our unit circle, which is what I have handy over here, to solve for the angle. The tangent of what angle is equal to the square root of 3? Well, if we go to the unit circle, alright, let's see here. We know that the coordinates here can be used to find the trig values. If we do sine over cosine here, that would be square root of 3 over 3 for my trig. This is 1, this would be square root of 3. And so we can see here that the tangent of pi over 3, or 60 degrees, would be a solution for the tangent. So one way to write this is we would say that x is equal to the inverse tangent of the square root of 3. And the inverse tangent of the square root of 3 is 60 degrees, or pi over 3. Okay. Now, you may notice that there are several other places around the unit circle where you get the ratio square root of 3. For tangent, might want to make a note of this. For tangent, we're going to find our solutions over the interval from 0 to pi. Okay, and that's the same for cotangent as well. But for sine and cosine, and for secant and cosecant, we're going to have to go the entire unit circle. We're going to find all solutions from 0 to 2 pi. And that has to do with the periods. If you remember, tangent and cotangent have a period of pi units. So we pretty much cover all solutions from 0 to pi. But sine and cosine, their periods are 2 pi long, so we're always going to go over the interval from 0 to 2 pi. Okay? So that's our answer. Alright, here's one for you to try on your own. Combine like terms. Okay. So go ahead and take a minute, try this one on your own, hit pause, and I will catch up with you in a second. Alright, if you've finished, here's how to get the solution. We're going to combine these two terms since they're alike. I'm going to subtract 2 sine x from both sides. 4 sine x's minus 2 sine x's, that's 2 sine x's, is equal to just the square root of 2. Okay, now we still need to isolate sine of x, so I'm going to divide this 2 over. We didn't have to do that in the previous problem, but just like a variable, if you have a coefficient out front and you want to get rid of it, you can divide it to the other side. And so we get this, the sine of x is equal to square root of 2 over 2. Alright, so I'm going to go back and grab my unit circle from the previous problem. Bring that over here. Okay, so now we're looking for where sine is equal to the square root of 2 over 2. Remember, y is our sine is our y coordinates, so I see that I have a y coordinate right here at pi over 4. That's where square root of 2 over 2 is. And then I have another one right here at 3 pi over 4. Okay. The only other places where it's square root of 2 over 2 is where it's negative, so we're not going to include those in our solution because it's not where sine is negative square root of 2, it's only where it's positive. So if you wanted to express this in degrees, you could also write that x is equal to 45 degrees or 135 degrees. Okay. All right, our last example today. Example 2 is going to involve when you have to take the square root of each side. And this usually occurs when you notice that you have a square symbol on your trig function. So here we have 4 sine squared x plus 1 equals 4. Everything else is pretty much the same what we did before. So notice I have a like term here, a plus 1. I can combine that with the 4 on the other side. So I'm going to subtract the 1 over. And I'm left with 4 sine squared x's is equal to 3. I still need to take care of this coefficient out front, so I'm going to divide both sides by the 4. So this is sine squared x equals 3/4. And now I can isolate sine by square rooting both sides. Be careful when you square root two sides of an equation like this. You always create two possible solutions. And that's the difference between this problem and the first one, is that when I square root both sides, I have to write plus or minus here. So it's going to be plus or minus. When you square root a fraction, you square root the top and you square root the bottom. What's the square root of 4 is 2. So now I need to find all sine x's where it's positive or negative square root of 3 over 2. So let's see. Here's my unit circle. So I'm going to have a lot more solutions this time because I have to look for both positive and negative square root of 3 over 2's. And again, since we're looking for sine, we're going to look at our y coordinates here. So square root of 3 over 2 occurs at pi over 3. At 2 pi over 3. Negative square root of 3 over 2 occurs at 4 pi over 3. And negative square root of 3 over 2 occurs again at 5 pi over 3. Okay. So you'll just list all solutions and you're done. Okay. For your last practice problem, try that on your own now with 3 cotangent squared x plus 4 equals 7. Okay, if you're ready for the solution, we're going to subtract the 4 first. So we're left with 3 cotangent squared x is equal to 3. Divide both sides by 3. So that cotangent squared x is equal to 1. And then when we square root both sides, we get that cotangent of x is equal to, here's the tricky part, plus or minus 1. Don't forget that part. So if we look around our unit circle, cotangent is the reciprocal of tangent. Luckily, the reciprocal of 1 is 1, so the 1's are the same. Tangent is 1, negative 1, 1, and negative 1 at these 4 locations. Now, what was our range of values for tangent and cotangent? We only had to go from 0 to pi, because that's the period length. So I'm only going to list the first 2 quadrants as my answers. X is equal to pi over 4 or 3 pi over 4. Those are both solutions. Okay, hopefully you enjoyed that little quick lesson. We're going to continue learning about how to solve more difficult trigonometric equations in our next session.